A really simple way to improve our interactions with a large language model like ChatGPT is to use the question refinement pattern. So this is a really, really simple idea, and hopefully it'll inspire other ideas from you of patterns that you could use. But the basic idea behind this is that we want ChatGPT or another large language model, whenever we ask a question, to try to improve our question. So the fundamental sort of intent or idea behind this is that we may not have as much information or underlying thought behind our question as ChatGPT has from its training data. So it may be able to infer patterns and other questions or words or things that are useful when asking questions on this particular topic or when trying to request something be done on a particular topic. So if you think about it, these large language models are trained on patterns in language. So if we give it maybe a more general question and ask it to refine it, it can use its knowledge of what other things are asked about in the context of the question we've given it, or what other words are typically associated with that type of question that might help improve our question, make it more specific, or provide additional context for it, other things. So sort of intuitively, what we're trying to do is we're using a sort of a general question, and we're tapping into the large language model's understanding of patterns and language around that topic of that question in order to create an improved version of it. Now, the sort of pattern behind this is really, really quite simple. All we need to do is say, whenever I ask a question, or you can give it some scope to this just for the next question or for the next 3 questions or whatever you want to do, you say something like, whenever I ask a question, suggest a better question and ask me if I would like to use it instead. So this is just a really simple idea. We want to always try to have the best questions, best prompts to interact with the large language model. So we'll simply tell it, whatever I do, ask or suggest a refinement. Now I'm going to show you kind of a little tweak to this that's a really helpful tweak to know, which is we can say, whenever I ask a question, suggest a better question and ask me if I would like to use it instead. So this is kind of a nice little refinement that's sort of helpful from a user experience perspective, because what we're doing now is not only are we going to tell the large language model to create the question that's better, but rather than requiring us to go and cut and paste it or tell the large language model, use the question that you just generated, we just have it say, do you want to use this question instead? And if we say yes, it uses that question. If we say no, it should use our original question. So it's kind of a nice little tweak to this pattern that can make it even easier to use. Now, every time we ask a question, the large language model will go and try to improve it. So let's look at an example of this. So I'm going to start off with a generic question, which is, should I go to Vanderbilt University? Now, if we look at this question, we can see it's really kind of ambiguous and vague. And if somebody was asking you this question, should I go to Vanderbilt University? Or as a faculty member, if somebody was asking me, should I go to Vanderbilt University? Well, not only is this a big decision for the person, but there's really not enough information at this point for me to make a decision. So a better question is going to help give me more information about the criteria that you're using to decide, do these types of, what are the pros and cons, how do you weigh them and decide if it's the right fit? And that's exactly what we see ChatGPT doing. ChatGPT says, sure, here's a suggested question. What factors should I consider when deciding whether or not to attend Vanderbilt University, and how do they align with my personal goals and priorities? And then it says, would you like to use this question instead? This is a really nice pattern because once we've sort of turned it on, we can begin asking questions and automatically getting better versions of our question. And one of the things that's nice about this is it also helps us to reflect on what we're asking for. And if we see a question come back like this, like what factors should I consider when deciding whether or not to attend Vanderbilt University, and how do they align with my personal goals and priorities, either we'll see that and see that's a really useful question, and that's how I really would have phrased it if I'd thought about it better or more. But sometimes what we'll also see is that the path it's taking us down is not the one we want to go, and we'll realize there's lots of paths, lots of ways of answering the question, and we need to give some additional context. So not only is this useful in many cases of getting a better question, but sometimes it's helpful to us to see that a question could be interpreted in many different ways. There's many different pieces of information that may be needed to make an effective decision. And so by seeing one version of a refined question, we'll identify missing pieces of information. So for example, if I really care about computer science at Vanderbilt, I might think, oh, well, I should have mentioned that I'm planning on majoring in computer science. Or if the town that I'm going to be in when I go to college is really important, then I might want to say something about Nashville and living in Nashville. You want to make sure that you think through the question really effectively, and this is a pattern that can help us really hone in on producing better questions, learning from the refinements to the questions, and also using the questions, the refinements to understand what's missing in the context that we might want to introduce in order to get a better output. An interesting property of large language models is that in many cases they can actually reason better if they break a problem down into a bunch of smaller problems. So sometimes they can even reason better if they explain their thought process. Now there's a number of sort of hypotheses about why this might be, but I think intuitively, if we can think about, a large language model may have seen particular problems broken down into a series of steps. So if it can go and follow the individual steps, it will know what to generate next in order to produce the output that's needed to solve a particular step. Now that's going to be discussed later in the course, these ideas of breaking things down. But right now we can actually tap into a simple technique, a simple pattern to help us with automatically breaking things down to try to get better answers out of large language models. And a simple way to do that is just to ask the large language model to always take questions or problems and subdivide them into a series of individual questions or sub-problems that could be useful in answering the overall question or in solving the overall problem. So we can simply program our large language model to do this. Now, the cognitive verifier pattern is exactly for this purpose. What we're going to do is we're going to tell the large language model, whenever you're asked a question, follow these rules. Generate a number of additional questions that would help more accurately answer the question. Combine the answers to the individual questions to produce the final answer to the overall question. Now, again, sort of intuitively, we can think about this. If we have a generic question or some particular question that we ask the large language model, it can go and tap into what it's seen, the patterns it's seen in the training data to see what are other questions that are often related to this question. So one, it can help it sort of think about, or collect from its knowledge base other questions that would typically be associated with that question. And when it's finding these other questions, there are likely to be other questions that are relevant to that question and will provide additional details or context to answer the question. And then when we go and give answers to all of those individual sort of sub-questions, it's then going to have additional context to give us a better overall answer. And it also helps us as the users to structure our thinking. Because when we go and ask and it begins breaking questions down, it'll help us sort of realize what are additional dimensions to the problems. So let's take a look at this in practice. So here I'm saying when you're asked a question, follow these rules, generate a number of additional questions that would help more accurately answer the question. Combine the answers to the individual questions to produce the final answer to the overall question. And ChatGPT in this case says, sure, I can do that. Just let me know what the question is and I will generate additional answers. So let's see what we can start with. Well, I thought of a question that I have no way of easily answering, and I don't know a whole lot about it. So I figure by asking a question that's sort of, I'm guaranteed probably to ask a question that's too generic and doesn't have enough information, this will be helpful to me. And so I asked ChatGPT, how many mosquitoes probably live in my front yard? I don't know the answer to that question. I didn't think too hard about it, but I'm kind of interested. What is the answer to this? How would I even figure this out? And so I asked ChatGPT that question. And so here's what it says. Well, it follows our prompt pattern. It follows the cognitive verifier pattern, and it generates a bunch of additional questions. Let's look at those questions. What is the size of your front yard? Well, obviously that's really important. If I have a bigger yard, I'm likely to have more mosquitoes probably. It's probably related to the square footage in my yard. What is the climate like in your area? That's obviously really important. You know, if I live in the desert or if I live at the North Pole, it's unlikely that there are going to be any mosquitoes. What time of year is it? Another great question. You know, I didn't think about that dimension to it when I asked the question, but I'm probably asking the question when I'm, you know, in the spring or summer when there's a lot of mosquitoes floating around in my yard and it's driving me nuts, but I'm not thinking about I need to include time in my question as well. Are there any bodies of water or standing water sources in your front yard or nearby? And obviously that's an important one because mosquitoes breed in water. And I actually knew that, but I didn't include that information in my original question. And then are there any plants or vegetation in your front yard that mosquitoes are attracted to? That's another important one. So we see now it's taken my original question and it's broken it down into a bunch of sub-questions that are going to help it answer the original question. This is really useful, and I've also learned something. Now to answer this, I'm just going to go back to it. If you'll remember, it had a series of questions, 1 through 5. I'm just going to go now and answer with 1, about 2,500 square feet. I honestly don't know, but I'm just sort of guessing. My yard's not that big in the front yard. This is probably actually an overestimate of the size of my front yard. I live in the southeastern United States. It's April. I'm not telling it, you know, seasons or things. I'm just going to give it the month. Which probably isn't specific enough. There's probably a difference between the date and different times within April, even within where I live. Then I tell it, no, there's no standing bodies of water in my front yard. And yes, there are plants that likely mosquitoes would breed in. And so then it goes and says, based on the information provided, here's an estimate of how many mosquitoes living in your front yard. And it gives me a number of things. It says with a front yard size of 2,500 square feet, according to some estimates, a single female mosquito can lay up to 300 eggs at a time. But it says in other things, and it kind of goes on to hedge its bets, which is a good thing, right? It says, in general, a typical mosquito population density in an area with standing water sources can range from 10 to 100 mosquitoes per square meter. However, since there are no standing water sources in your yard or nearby, the density could be lower. And then it goes on to say it's difficult to provide a precise estimate. However, it's possible that there could be anywhere from a few dozen to a few hundred mosquitoes in your yard, depending on various factors such as species, climate, and the presence of vegetation. That's pretty good. The fact that it's gotten this down to a few dozen to a few hundred, that's a tighter range than I would have expected. And also just sort of sets my expectation. In the middle of summer, when I go out in my front yard, I would swear it was in the thousands. I'm absolutely dying as I'm eaten alive by mosquitoes, and so I typically think it's a much higher number. But based on this, it may be wrong, it may be erroneous, but it actually gave me some fairly good reasoning. One of the things that's also nice about this is I'm less skeptical of its answer being completely wrong because it asked me a bunch of reasonable questions to derive its answer. It also gave me a bunch of facts which I could go and follow up on, like how many eggs a female mosquito will lay, the density of mosquitoes in areas with water. But it gave me kind of a pretty good answer, and it gave me a bunch of questions that I could ask to improve that answer. Now I'm going to go back. I'm going to actually qualify that. It said it gave me a pretty good answer, but the truth is I have no idea. I'm not an expert on this topic, and as with anything that we get out of one of the large language models, I would highly encourage you to verify the output. But I think this is interesting because at least at the very minimum, it helped me learn about, through this question, what might influence the number of mosquitoes in my yard and give me things that I could go and follow up on and verify, see if they're correct, if these facts hold water, see if these questions really are useful. But they certainly look like valid and important questions. What is the size of your front yard? I'm not sure that I even need to go research that. A larger yard is likely to have more mosquitoes. What is the climate like in your yard? I know that matters. What time of year is it? I know that also matters from personal experience. Are there any bodies of standing water sources in your front yard or nearby? I know that matters. That's sort of general knowledge in the southeastern United States. And are there any plants or vegetation in your front yard that mosquitoes are attracted to? And I actually happen to know that that is also an important factor. So it's actually given me a bunch of really good questions. It's given me some facts related to those questions, which I would have to go verify and I don't know as much about. But it is a really helpful tool for automatically taking a question, breaking it down. I can see sort of its reasoning about how it's going about and thinking about this. It improves my reasoning about thinking about how I might answer this question. And in many cases, what we'll see is having the large language model break down the question will help it give a better answer to us so that we'll get something that's more accurate. We discussed the persona pattern and how we can use it to give the large language model all of this rich information about what it's supposed to do and what it's supposed to output with a very little bit of work on our part. All we have to say is act as, and it will know what it's supposed to do and how it's supposed to format it and the types of things that it's supposed to incorporate into its output. Now, sometimes what we'd also like to do is we'd like to do the same thing, but rather than focusing on who the large language model is supposed to act like, we want to have the large language model produce an output for a particular persona. So this is called the audience persona pattern. The idea behind this is we want to tell the large language model, you need to produce an output for this audience persona, for this person or thing, so that it can think about how to tailor the output. And it will use its knowledge of the audience to make sure that it generates an output that is appropriate for that audience. So rather than saying you don't do this or having a whole bunch of different rules describing what is and is not okay to go into the output, instead we say this is the audience of your output. This is the audience persona. And so with the audience persona pattern, we can get a similar type of reasoning and ability out of that we got from the act as this persona, using the persona pattern. We can get that by saying, here's who you're providing the output to. This is the persona of the audience in order to get interesting outputs. So let me show you an example of this. So we're going to start with the example of large language models, which we've been studying in this course. And we're going to say, explain large language models and how they work to me. Assume that I have no background in computer science. So we're giving it a persona of who I am. We're saying, assume that I have no background in computer science, and that's telling it who is the persona, who is the audience that I'm giving this information to. And so it says, sure, let's start with the basics. And I want to call out just a couple of things. It starts with a very sort of intuitive way of describing this. A large language model is a type of computer program that's designed to understand and generate human language. It's a bit like a virtual writer that can understand and create sentences in a way that sounds natural to humans. And so it's not describing it like it would to a computer scientist. It's describing it to be, something that is accessible and approachable to anyone. Language models are used in many applications such as speech recognition, machine translation, and chatbots. Now let's talk about large language models. The word large refers to the size of the language model, and it goes on to describe it, and it says parameters are like adjustable knobs that the model uses to learn patterns in the language. So it's describing what a parameter is in a sort of accessible way. And it goes on and it talks about all the different steps in creating this. So it did a good job, right? I said, assume that I'm not, I don't have background in computer science, and explain it to me. And so it made sure in its explanation that it had the right information and then presented it at the right level for me. So let's go a step further. Let's show you how interesting this can get. I'm going to say, explain large language models and how they work to me. Assume that I am Christopher Columbus. So notice, now I'm giving it something completely different. I don't know how you would explain large language models to Christopher Columbus. So it's going to have to use and draw on information in its training data and patterns related to Christopher Columbus and history to try to figure this out, right? I'm giving it an audience persona that's a tricky one that I wouldn't know how to do easily. And it says, greetings, Christopher Columbus. As an explorer of 15th and 16th centuries, you may not be familiar with the concepts of Computer Science and Artificial Intelligence. And I don't know how well this really works, but it's still pretty good that it's doing it. I'll do my best to explain it. Imagine that you have a magical scribe, a being that can read, write, and understand many languages. This scribe has spent years reading countless books, scrolls, and manuscripts from all over the world. It has learned from poets, scholars, and storytellers. The magical scribe has a special ability. It can predict what comes next in a sentence. For example, if you say to the scribe, "The ocean is vast," it might respond with "mysterious," completing your sentence in a way that makes sense. And so you can see how all we did is we said, you're going to explain the exact same thing, but you're going to assume in the first case that I don't have knowledge of computer science. And then we said, now you're going to assume that I'm Christopher Columbus, right? And so it completely changes how it describes large language models. And it's actually doing a pretty good job. So it's saying here, like Christopher Columbus doesn't know what a computer is. You know, Christopher Columbus, but maybe this concept of a magical scribe, right? And a magical scribe could be a concept that could make sense to Christopher Columbus. And then he's explaining how large language models predict the next word. He's saying the magical scribe studied all of these, all of these scrolls and poems and different things and learned to figure out what is the next word in a sentence. And now we're going to use that magical scribe, and we're going to talk to the magical scribe. So he's explaining, the scribe like Christopher Columbus, as he's going to understand it. As Christopher Columbus will be able to look at the text and kind of understand that, like, okay, I have this large language model, and now I've got this magical scribe. It kind of makes sense on what that means and like how that would possibly work. So now let's look at a third example. We say, explain large language models and how they work to me. Assume that I'm a second grader that gets bored easily. And so again, we're given a totally new persona, and we're also refining this persona. We're saying I'm a second grader, and here's some additional details about me. I get bored easily. And so now it goes and says, okay, I'm going to tell you something super cool called a large language model. Imagine having a robot friend who's really good at playing word games. This robot can finish your sentences, answer questions, and even tell you stories. Here's how it works. Reading time. The robot friend loves to read. It reads lots and lots of books, websites, and all kinds of things with words. And so it's explaining this concept of, similar to as it explained to Christopher Columbus, it told Christopher Columbus, the large language model is like a scribe that's read all of these scrolls and poems and things like that. And now the large language model is explaining to the second grader, it's like a robot. And the robot loves to read. It reads books, websites, and words. And so now it's switched up the description based on the persona of the audience. And then it goes on to describe all of the different aspects again. And you could go through and ask it, to describe it in many different ways. So if we wanted to go back and we wanted to say, well, let's switch it up from a second grader, and let's say, assume that I only accept explanations in math. And then we could say something completely different. So now it's saying, okay, language model is a probability distribution, and it's trying to give a mathematical explanation of what a large language model is. And we can see that we're getting something completely different. And each time, we don't have to necessarily think through, well, how would I explain this to Christopher Columbus? What would the rules be to describe how that output should look? We don't have to tell it what the output should look like. We tell it who the audience is, the persona of the audience, and then we get all of that rich capability around it. So just like the persona pattern is really useful in tapping into large language model capabilities, the audience persona pattern is sort of the complement to it, and is also sort of an equally powerful thing that we can use to basically get really interesting and powerful output out of large language models. Sometimes we need the large language model to ask us questions, to really guide the process of solving some problem that we have, are helping us obtain an answer or an output that we need. And we may not know what are all the steps to achieve that goal. And so what we'd really like to do is that we'd have to have the large language model ask us questions. So whenever we want the large language model to ask us questions, the pattern that we can use is called flipped interaction. And so the idea behind this is rather than, we're going to flip the interaction rather than us providing questions and the large language model providing answers, we're going to flip that and we're going to have the large language model ask us questions and we're going to provide the answers. And we can do this in a number of different ways. We can do this to play games. We can do this in order to try to reach some goal, like the large language model keeps asking us questions until it gets enough information to achieve some goal. There's a variety of different ways that you can use this, but this is incredibly helpful when you don't necessarily know everything that's needed, or if you want to be tested or quizzed on something, anywhere where you don't want to be in the driver's seat. You want to really be helping provide information, but you don't want to be formulating the questions or tasks. So let's take a look at an example of the flipped interaction pattern. So the key to this is we start off by asking the large language model to ask me questions, and then we give it some topic that we're going to have it ask questions on. So ask me questions about fitness goals until you have enough information to suggest a strength training regimen for me. When you have enough information, show me the strength training regimen. Ask me the first question. Now this is the basic pattern, is you say ask me questions on a particular topic, and then it's more helpful usually if you give some goal. Why are you asking the questions? Are you trying to have it quiz you? Or are you trying to get a fitness regime like we're in this one and have a fitness plan? Like what is it you're trying to achieve? And the more information, the more context you can give about what you're trying to achieve, the better questions it'll be able to ask you. Now, other things you can do are you can tell it how many questions to ask you, how many questions to ask at a time, a variety of different things. But one really handy thing you can do is end the flipped interaction prompt with ask me the first question. So one thing that you often want to do is do it one question at a time. Now sometimes you'd like to have like 10 questions listed and you can answer them, 1, here's my answer, 2, here's my answer, 3, here's my answer. And you can certainly do it that way if you want to get it all at once and think about it all at once. But a lot of times I like to do it one question at a time. And so if you want to get that one question at a time behavior, usually a really reliable way of doing that is to say, ask me the first question at the end of the prompt. So we're going to generate this fitness plan. So we say, ask me the first question. And it says, great, let's get started. My first question is, what are your specific fitness goals? Are you looking to build muscle mass, increase strength, endurance, performance, or achieve a particular goal? And I go on to say, I'm looking to build explosive power and also prevent patellar tendinopathy from doing jumps on a mountain bike. Now, I don't know if this is a correct pronunciation of patellar tendinopathy, but this is what I've sort of looked up as I've started to experience some pain in my knees at certain times when I've been doing a lot of jumps on a mountain bike. And so I looked it up and this seems to be the reason for it. And so I'm providing that information because I don't necessarily know. Well, actually I do know because that's part of the reason I picked this one is I could fact check it a little bit against what I've read on the internet. But I wanted to generate a fitness regime for me. And this is something that I've actually been doing, is figuring out what exercises I should do to help out, my knee and strengthen so it doesn't happen again. And then it asks, do you have any current or past medical conditions or injuries that may affect your ability to participate? Additionally, have you been diagnosed with this, or are you looking to prevent it proactively? And I give it some information. And then it goes on and it asks me how many days per week I can dedicate. And additionally, do you have any access to a gym or fitness equipment? I'm specifying I can work out 5 days per week for 30 to 45 minutes at a time. And then we finally get to the point where it actually generates a full sort of fitness regime for me of what I'm going to do to work on this. Now, what's really interesting is it's gone through and it's taken into account the answers from my earlier questions. And I know that because I've been looking for what are good exercises to help work on this issue with my knee that I've been having. And these are exactly the types of things that you see recommended, like the goblet squat, the split squat is one that you see a lot of times. A lot of different types of squats and things are very helpful, and these are the types of things that I see. But it's also taken the overall context that I'm looking for, weight training. It's gone and generated the entire weight training regime. Now notice at the very beginning, I said when you have enough information. So I said, show me the strength training regime. And so this kind of shows another important sort of power of this prompt pattern, this flipped interaction pattern, is we give it what we're trying to achieve, and how much it should ask you. And basically we set the goal as ask me enough until you have enough information to show me the training. And so it asks questions until it thinks it has enough information and then generates the output. Now sometimes what you'll see when you ask questions to a large language model is it'll tell you, well, in order to do this well, I'd need to get a bunch of additional information. Or it might generate a generic initial plan and then say, but if you provide additional details to me, I might also be able to do blah, blah, blah. And so what we see here is this is kind of getting rid of all that. Let's skip that step of getting something generic or being told that there's not quite enough information, you need to answer questions for us, and let's just say, go ahead and ask us the questions that you need until you get there. Now, this can also be used for doing other things like quizzing, playing games, anywhere where we want to have knowledge in the large language model drive the creation of the questions. And this is really helpful when it has theoretically or been trained on knowledge or patterns in language that will be useful in creating the questions and are things that we don't possess ourselves. So whenever that's the case, it can probably go and more effectively think up questions. So if we say, okay, I need a fitness regime and I have patellar tendinopathy, I may not know, what are the types of questions that you should ask somebody who has this. I may not know what are the types of exercises that are commonly discussed if you have this condition, but it has been trained and seen patterns of language where when people were discussing this particular condition, these are the exercises that were discussed. These were the additional questions that were asked in order to select exercises. And it has access to those patterns from its training data that then help it to select good questions to design that appropriate training plan. So whenever you need the large language model to ask you the questions, or you can think about a customer service example where you're trying to diagnose some problem that a customer has, or automate some response, and you need to collect information and then take action, the flipped interaction pattern is a really powerful prompt pattern to use to do that.